So hi everyone, my name is Nilmurugan Balamurali and I'm from section DEE3B and I'm from Electrical Engineering Department. My matrix number is 01DEE24F1041. So in this video I'm going to present to you guys about environmental control in coal-fired power plant system. So I hope you guys will like my presentation and don't forget to subscribe and like my video. So thank you for watching. So guys, before we move on to important part of my presentation, let me give you guys a brief introduction about our coal fired power plant system, and also environmental control. So coal fired power plant are widely used to generate electricity by burning coal to produce steam, which drives the turbines connected to generators. They play a significant role in meeting global energy demands but also contributed to environment challenges such as air pollution, greenhouse gas emissions, and ash disposal. To reduce these impacts, modern coal-fired power plants are required with environmental control systems like uh, electrostatic precipitors, scrubbers, and filters that helps to control the emissions of sulfur dioxide, nitrogen oxides, and uh, particulate matter. These technologies are essential in ensuring that power generation is balanced with environmental protection. Now I'm going to explain to you guys about risk of air pollution from coal combustion. So the coal combustion produces a lot of toxic gases. So we are going to see one by one effect of each toxic gases. So first of all, we have particulate matter. The fine dust particles that can cause respiratory diseases like asthma, lung cancer, and reduce visibility. Next, we have sulfur dioxide, which also known as SO2, where it contributes to acid rain, which damages crops, forests, and water ecosystems. Next, we have nitrogen oxide, which also known as NO. So this gas is lead to smoke formation, ground level ozone, and respiratory irritation. Next, we have mercury and heavy metals, harmful to human health, especially the nerve systems, and contaminate water bodies. And finally, we have carbon dioxide, which also known as CO2, main greenhouse gas, which driving climate change, leading to global warming and extreme weather changes. So now I'm going to explain about the recommended control strategies that we can follow to reduce the air pollution from coal combustion. So actually we have four major control strategies, which is emission control technologies, cleaner combustion particles, energy efficient and transition, and lastly policy and monitoring. So first of all, we are going to see about the emission control technology. So emission control technology, first of all, we have electrostatic precipitators, which also known as ESP, and fabric filters. Function of this strategy is to capture fine particulate matter. And next we have flue gas desulfurization, which also known as FGD, which uses to remove sulfur oxide emissions, which also known as scrubbers. Next we have selective catalytic reduction, which also known as SCR, to reduce nitrogen oxide emissions. And finally we have activated carbon injection to control mercury and heavy metals. And secondly, we are going to see about the cleaner combustion particles. So this strategy used to use lower sulfur coal or coal washing to reduce pollutants, and also apply fluidized bed combustion for more efficient and cleaner burning. And thirdly, we are going to see about the energy efficiency and transition strategy, which improve the plant efficiency to use less coal per unit of electricity and gradually shift towards the co-firing with biomass to reduce net carbon dioxide, and to invest in renewable energy like solar, wind, and hydropower plants to reduce long-term reliance on coal. And fourth, we are going to see about the policy and monitoring strategy, where we can implement strict emission standards and continuous monitoring, and promote carbon capture and storage, which also known as CCS, to reduce carbon dioxide emissions. And finally, we can encourage energy conservation and sustainable usage at consumer level. As a conclusion for coal combustion poses serious environmental and health risks due to its air pollutant emissions. However, with the adoption of advanced emission control technologies, cleaner combustion particles, and gradually integration of renewable energy, it is possible to meet the both energy demands and sustainability goals. As an environmental officer, we need to ensure that the industry does not only comply with the regulation but also adopt the strategies that protect public health and the environment while moving towards the low carbon future. So now I'm going to explain to you guys about the block diagram for environmental control strategy for coal-fired power plant system. So first of all, we have coal supply, where it goes from coal supply to boiler, where coal is fed to the boiler and burned to produce high temperature, high pressure steam. And next we have boiler to flue gas, and also to emission stack, which also known as ESP. This is because flue gas from combustion goes to the emission control unit ESP to remove the sulfur dioxide and acid gases. Purpose of this process is to reduce air pollution before gases released to the atmosphere. And next we have boiler to ash handling system, where ash is collected and sent to the ash handling unit for safe disposal. Purpose is to prevent the soil or water contamination and recover useful materials. Next we have steam, which goes to steam turbine, where high pressure steam expands through the turbine, covering thermal energy into a mechanical. Next we have turbine to generator, where exhaust steam is condensed back into water in the condenser to improve efficiency and recover feeder. Next and finally we have condenser to cooling tower or pond, where warm cooling water passes to the cooling tower or pond to dissipate heat before reuse or safe discharge. Purpose of this process is to reduce thermal pollution to rivers or lakes and save water. Guys, now I'm going to explain to you guys about the environmental control strategies for components that are responsible for the pollution. So actually we have three major environmental control strategies. So first of all, we have emission stack, and then we have ash disposal, and finally we have cooling water system. So first of all, we are going to see about the emission stack, which also known as air pollution control, where we can install electrostatic precipitators, which also known as ESP, or fabric filters to capture fine dust and particulate matter. And we also can use flue gas desulfurization, which is also known as FGD, or wet scrubbers to remove sulfur dioxide or nitrogen oxide gases before it releases to the atmosphere. And finally we have add low nitrogen oxide burners or selective catalytic reduction, which also known as SCR systems, to reduce nitrogen oxide emissions. Next, we are going to see about the second control strategy for ash disposal, which also known as solid waste control, where we can implement secure ash ponds or landfills with lining to prevent soil and groundwater contamination. We also can recycle fly ash and bottom ash into cement, bricks, and road construction materials. And finally, we also can introduce dry ash handling systems to minimize the water contamination. And lastly, for environmental control strategy, I'm going to explain to you guys about the cooling water system, which are also known as thermal pollution control. In this system, we can use cooling towers to release heat into the air instead of directly into the rivers or lakes. We also can apply cooling ponds to allow the water to cool naturally before it's discharged. And finally, we can use to adopt closed loop cooling systems to reuse water and reduce freshwater consumption. Guys, now I'm going to explain to you guys about the two differences between two environmental filtering methods, which one is electrostatic precipitators, which also known as ESP, or fabric filters, which also known as baghouse. So first, in terms of effectiveness, ESPs can remove fine particles efficiently but may struggle with very small particles, while fabric filters achieve extremely high collection efficiency regardless of the particle size. Second, in operational costs, ESPs are generally cheaper to operate but expensive to install, while fabric filters have lower installation costs but higher maintenance due to the frequent back replacement. And third, we have regarding complexity. ESPs required advanced electrical systems and precise operating conditions, whereas fabric filters are simpler in design and easier to operate. Finally, in terms of environmental impact, ESPs produce minimal waste but may release ozone during operation, while fabric filters generate dust cake that must be safety disposed but do not release secondary pollutants. These differences show that the both methods have a strengths and limitations depending on the plant's need. So now I'm going to explain about the how SDG, which also known as Sustainable Development Goal 7, contributes to the affordable and clean energy goals. So the proposed solution directly supports the Sustainable Development Goal 7, which also known as SDG, affordable and clean energy, by reducing air pollutants through ESPs or fabric filters. The plant ensures cleaner air quality and healthier communities while still generating electricity. Recycling or safely disposing of ash helps to conserve resources and reduces land pollution, aligning with sustainability principles. Using cooling towers minimizes the thermal pollution, protecting biodiversity and maintaining water quality for local communities. Overall, these strategies allow the coal plants to operate more efficiently and responsibly, promoting affordable electricity access while reducing environmental harm, thus contributing to both energy security and global sustainable goal. So finally, in conclusion of my presentation, coal-fired power plants remain an important source of electricity, but their operation can have a significant environmental consequences if not properly managed. The use of environmental control systems such as scrubbers, precipitators, and filters helps minimize harmful emissions and reduce the overall ecological footprint of the coal-based energy. By combining efficient power generation with effective pollution control, Coal-fired power plants can continue to supply while energy while supporting efforts to protect the environment. So that's all from me. Thank you for watching. I hope you guys really uh, enjoy and like my presentation, and don't forget to like and subscribe to my channel. Thank you.